Hello, everyone. Let's talk about functions. So, functions are kind of interesting in that technically they're just objects, but we can call them, and we can have, when we call them, they evaluate to whatever their return value is. They can also really do pretty much anything. Functions are probably the most magical thing in JavaScript. So let's talk a little bit more abstractly about what a function is. So a function has a name, optional. Function has parameters. Also optional. A function has a return value. It always has a return value, but they're optional too, I guess. You don't need to explicitly write them every time. Name, parameters, return value, and a body. I guess that's also optional. Okay, so these are the 4 different parts of a function. JavaScript is kind of unique in that it has more different syntaxes for writing functions than I think any other language. But they all have these exact same things, just different ways of writing them. For example, I do function add A and B, and I do something like const sum equals A plus B, return sum. It's that thing that I'm always mad at you guys for doing, saving something in a variable and then immediately returning it. Just trying to illustrate something. That's the name. These are the parameters. This is the body. This is the return. Let's look at that same function as an arrow function, as an anonymous arrow function. So this one, those are the parameters. This is the return value. That's it. Exact same function. Doesn't have a name, doesn't have a body. Still a function. Still the same function, actually. If I'm doing the method shorthand on an object, I might have some property, and then that might have a method. Name, parameters, return value. Same function, just now it's on an object. Oops, come on. Ask me some questions about this syntax.
So this
Okay.
might be the
Sean.
This might be the first time that we've kind of encountered this where a name for a function could be optional. So
Yeah.
for our second example, a b
Hmm.
fat arrow a plus b, how would one call that?
You'd call it by passing it into something that's expecting a function definition, like map.
So that was my exact, because I get the idea and I like the sorter function, but it's not something you can define early and call later, right? You have to do
Correct.
it immediately. That's
Exactly.
where I've been struggling.
So
Okay.
yeah, you do it with things like event handlers or mapping functions or something like that, where you're not reusing that function anywhere else. So you just define it in place, and if you're defining it in place, it doesn't actually need a name. Now, here's a kind of curious thing about that. The names are optional. You can still do them. Check this out. And this is another one of those things that not a whole lot of pro JavaScript developers really know either. But if I'm doing like an event handler, so I've got some element, add event listener for click slick. Okay, so I do that function inline. You can still give it a name. That's allowed. This thing seems mad about it, though. Let's see. It's not over here, though. Come on. Nope, it's not that either. And I could have sworn it was this. Oh, maybe you have to use the function expression syntax. There we go. That's it. So yeah, you can, if you use the function keyword, you could give those like defined in place functions a name. Almost nobody does, but you're allowed.
Okay. Cool.
Well, wouldn't there be no point to adding a function name on this just because you wouldn't be
You might as
calling
well make
back
a
to it?
function.
Right.
Yeah.
So, super good point. The reason, like, there's not a ton of good reason to give it a name, which is why people don't do it. But it does technically make your error messages a little bit better because it says the handle click function threw an error at line 2 or whatever, rather than an anonymous function threw an error on line 2. It's like a little bit more helpful, but yeah, most people do it like that or like that, both of which are the same thing.
Kyle, I hate to distract you, but apparently there's something wrong with the Sika site or
Uh-oh.
Discord.
Yeah, Heroku's been having a rough couple days. All right. More questions about functions.
Yeah, I had one question. I know you said earlier that a function is essentially just an object that you can call back on. And is that why you're able to put it inside of an object or right underneath another object or in an object with like that last syntax that we have as an example where your name, Kyle, which is obviously
Sure.
an object, and then that function we have listed also as an object underneath that?
So, this is huge. Functions are just values. I'm gonna let that one like sink in for a sec. Think about things that were values. Let's go back to that that part of the site. If it's up.
Yeah, you can't get on it. It's going through it. Hey, how did you get on?
Well, I don't know that I am. I don't see a response back yet.
It went further than mine did, though.
I had to do a hard refresh to get where he's at.
Yeah, so if you look at those errors, problem is this XHR request.
I have the function page pulled up under the reading code section. Do you want me to share real quick?
Ooh,
the part you're looking?
Bless you. Do it.
Yeah.
All right, go to the reading code link. Yeah. Scroll down to the bottom. All the way. And that programming concepts and JavaScript link at the bottom. Yeah. All right, so yesterday we talked about data types. Data type has like a list of legal values, a list of legal things that you can do with those values. And then if you scroll down to values, that's the unique part of the data. So like Booleans, only legal values, true and false. Null, undefined, only legal values for those are null and undefined. Numbers, we talked about like there's a lower limit to that, there's an upper limit to that. There are every integer in between those we can do. We can also do decimals, kinda, sorta. The more precise our decimal is, the less precision in like the rest of the number. So if you have really long decimals, you can't also have really long numbers. So, so those are legal values for a number. And then when we look at things like objects, objects are key value pairs. So some key, some value. Values can be any data type. So value of an object can be a Boolean, it can be a string, it can be an object. So more key value pairs, more key value pairs. But we also had a couple of like special kinds of objects. So for example, an array is an object. So an array is an object where the keys are numbers and the values are whatever. But like that's the magic trick there. So we do like Kyle.name, or if we do Kyle at 0, like that's just looking up the value of whatever the key of 0 is. Promises are a type of object. DOM nodes, like anything that's cool in JavaScript is probably some kind of object, including functions. So if you look down at the bottom of that list of values, that's just a value. And so we can use it all the places that we can use values, such as the value of a property in an object, or passing it into a function, like we do with map. But yeah, a function is just an object, which means it's just a value. That's not true in every language, by the way. That's like a specific concept in a paradigm called functional programming. I know some of you were looking at the procedural paradigm stuff from the new unit. The idea of using a function as a value, that's a functional idea. It is throughout JavaScript. It is probably the single coolest thing in JavaScript. There's actually an academic term for it. It's called a first-class function. First-class function means that a function is not a different kind of value than anything else. So we can save them in variables, we can make copies of them, we can pass them into stuff, we can use them as values in objects, etc. Questions about that idea? All right, thank you, Bryce.
Of course.
So let's see some examples of that in action. So if I make a sum function, well, let's look at some different ways I could do that. Okay, so like that's the first one you learned. Sort of makes sense, right? You can also do that's called a function expression. It's called a function expression because that is an expression. Who can tell me what the definition of an expression is?
It evaluates to a value.
It evaluates to a value. Functions are objects, objects are values, ergo, this is an expression. So, versus this, which is a declaration. All right, so this evaluates to this function value, but I don't use it any differently. Regardless of which one I'm referring to, these do the exact same thing. It's a special value because you can invoke it. You can't invoke a Boolean. You can't invoke a string. You can't invoke normal objects. You can invoke functions, though. By the way, another kind of cool thing. This is shorthand for that. Invoking a function, that's just a method that's on the object. If that helps it make more sense to you, keep it. Otherwise, don't worry about it. But the
What was the null part of that?
this is the context that will be given to the thing. It specifically refers to this value. We're not going to talk about this for a good while because it's the most confusing concept in JavaScript. Every language has stuff that like doesn't fit in neatly, and it's kind of like, oh man, I couldn't get the corner on this working, so I just kind of balled it all up. In JavaScript, that's the this keyword, and so you can live almost your whole JavaScript career without having to learn how this works, which is good because it has 11 different meanings.
Isn't the this statement part of the classes for the template of objects?
Part of the classes for the template of like prototypes and stuff.
Yes.
Yeah, like that's one of the 11 things that it can be.
Oh, okay. So it has more uses than that one thing.
Very much
looking
so.
at. Okay.
There's other languages, for example, Java, where this is very straightforward. So we'll probably do more this stuff with Java than JavaScript. But
Gotcha.
JavaScript, that was the gross like junk drawer that I threw all the design decisions into. But yeah, that's what that first parameter is. But yeah, just a value. We can save it in something. I could have written this like this. Could have written it like this. All of these are the same. Name, parameters, return statement. Name, parameters, return statement. Name, parameters, return statement. If I had a body in here, this is the body. Body, return statement.
So on the third option for the arrow function, the return statement's built in, and that's why we don't write it.
Exactly.
The curly braces. Okay.
So if your return statement is all there is to the body, then you can put it right here, and it's called an implicit return. if you need more than one statement, so like, that's the return statement. That's the return statement. That's an assignment. Assignments are statements. So if you need more than one statement, you got to open up the body and put the curly braces in and use the return keyword and all that stuff. But a lot of this stuff that we do in data transformations is just like a pretty simple statement like that. So you can implicitly return it a lot of the time.
Can you say that last part one more time? Like, if you have to have more than one statement, then you have to open up the body and put in the root. Okay.
So, like, that's a statement. If that's all I'm doing, then I could do this. If I need to do some other calculation, if I need to assign variables, like, rather than just trying to jam the entire thing into one line so that you get the implicit return, fuck it. Just open up the body and write some statements.
Okay.
Is it okay if we always use the braces just to avoid confusion in the beginning?
Yeah, that's fine. It doesn't break anything to do it longhand every time.
I've seen sometimes with like using the arrow function that when a parameter is placed, like if it's 1, there's no parentheses, that's valid, correct?
Correct. So if we had double and it takes in a number and then returns that number doubled, the parentheses are optional. So I can do that. That's fine. Your formatter might even add it for you, but that's legal also. What the times you need parentheses are anytime it isn't 1. If it's 0 or if it's 2 or more, it needs parentheses. So if it was like shout and it doesn't take any anything in, I still need the parentheses. And if I have 2 things, gotta have the parentheses too. If it's 1, they're optional. And like, that sounds arbitrary and stupid. It, like, this is what functional programming looks like. And in fact, if you did like calculus, where you have like f of g of x, like it uses the same notation. So it would be like some higher order function would be like f of g of x. Oops. G of... No, I guess it would be. Yeah, so like you can chain those functions too. That's pretty advanced, but that's why the syntax is what it is, because it's closer to the math syntax. More questions about syntax?
Is there one of these that you're hoping that we use, like layout wise, syntax wise, more than others?
That's a good question. I really like function declarations. That's something that I'd say is probably 50-50 out in the JavaScript world. There's a lot of people that just moved on from them and won't do anything other than arrow functions for everything all the time. I still think that these have a place. The reason that I like them is that, let's say I comment all this out. I'm just looking at this one. I can do that, or I can do that. I don't need to define the function before I use it. That's not the case with arrow functions. So like, that works, that's an error. The counter argument is that, like, yeah, it should be an error. That's confusing to use something before you define it. I don't think it's that bad. I think it lets you tuck away the details of how something is implemented down at the bottom of the file and then lead with the parts that are interesting. But that's an old man Coverly opinion that is not shared by everyone. When I'm not doing function declarations, I like these. Probably don't use those anymore. Let's say this is fine, also fine. Yeah. These and these are the same thing. There is some minor differences on how they handle this, but we're not using this, so it doesn't make a difference to us. But yeah, I really don't see that anywhere anymore. If you're doing a function expression like this, just use the arrow function, either one.
Codecademy has both of them, the function expressions and the arrow concise function. So they're still out there.
Oh, they definitely are. They're not going anywhere. But with like quality code stuff, probably not. More questions about this? All right, your turn. So let's say, I want you to head over to Inbox. Apparently the site's back up. Verify that. Yep. I would like you to write a function that accepts a number and a string and let's see, how do I want to do this?
I got the something weird happen, and then when I hit refresh, I'm getting the spinning circle.
Try doing a hard refresh. Write a function that accepts a number and a string and returns the string. Let's see. Got it. And returns the first number of characters of that string. All right, so the idea is that writing a function that takes a number and a string, and you're going to return the first whatever characters of that string. So if it's like hi is the string, and 1 is the number, then you're going to return H. If it was 3 and the string was hello world, then you'd be returning HEL. So yeah, there you go. Slice is probably the function that you want for that, but write me a function that does that. Go! Although the prompt isn't working for me now. Come on, man.
Yeah, the site's still...
It's still
The
spinning
site's
for me.
still doing something funky.
All right, give me a sec. All right, irritated
Would
as
you-
I am that this isn't working right now, how about just do it? We'll talk about it. I'll give you 2 minutes.
Can you post the question in chat in Zoom?
How about I put it right here?
That'll work too. Thank you.
All right, go for it. There's the code for getting the first number of characters of something, by the way. All right, hopefully what you wrote was a function that accepts a number and a string. So we got to give it a name. So that would be like first n characters. And it accepts a number and a string. So maybe call that one count. Maybe that one string. And then this was the code that makes that work. So we have to figure out which parts of this are variable, which parts of this stay the same. Hey, that string here, that probably is variable. So we do that. And then that's probably count minus 1, because it's an index. There you go. Should probably look like that. Let's see if it works. So if I call first n characters 2 and I run this file, oops, probably gotta log it too. That helps. Yep, did something wrong.
I didn't have to do the -1 to get it to work. Like when I just do number, it does too. Like it does the number I want.
Excellent. Maybe I read the
That's how I wrote mine, so I was feeling real dumb, which I was already because I guessed, but I just had to string a number and slice the number.
Well, there you go. Magical.
I don't know if it works though.
So if I do hello world, what do I get back? Ta-da! So other ways we could have written that function. Could have done it as an arrow function. Does it still work? Still works. Exact same thing. Could I have done it as a one-line arrow function? Still works. Questions?
Could you have put the console log within the function?
Yes. So if I did that, it could have been something like that. There we go.
Nice.
That reminds me, a thing that approximately every student of all time has had a hard time with is the difference between returning something and logging something. Who can give me a good explanation of the difference between returning and logging?
Returning doesn't print anything to the screen.
Yep.
And console doesn't actually return anything. It just prints to the screen. It doesn't really give you a value. It just gives you a visual readout.
Outstanding. Terrific answer. So if I pass something into the sum function, the return value is what I get out of that. I get a value. I can reuse that value. I can save it in a variable. I can pass it into a different function. I can do whatever I want with it. If I print the sum, nothing comes out. It just puts it on the screen. This doesn't put anything on the screen. That does. You can also chain those so that you get the value that you want and then print it to the screen. But yeah, returning and printing are different. We have all kinds of different ways that we could print something. We could make a DOM node, throw it in the DOM tree, print it to the console. You could print it out on a piece of paper. There's like tons of different options for output on that. Return value makes the function evaluate to that value. This expression evaluates to hello. That means it's interchangeable with the string hello. So like strings have a length method. Guess what? So does this. Because all of that is a string. That's what it evaluates to. Oh, I could slice it again. Nah, just give me the first character. All of that is equivalent to the string H. I could to uppercase that. If I log all that, this is part of the reason that you don't want to do the console logs as part of the function. Because if it's console logging, then that evaluates to the return value of a console log, which is undefined. Statements always evaluate to undefined. So I do that, console log it, should get a capital H. And I do. Oh, I suppose it was already a capital H, but if I lowercase it. There we go. Because that function call evaluates to the string hello. I can slice the first letter off of it. So that's equivalent to lowercase h. Lowercase h, that's a string. I can call it to uppercase on that. And that makes it capital H. That's not any different than breaking it into steps either. So if I did that as this will be hello. This will be H. This will be uppercased. That and that are the same thing, just more steps. Questions? So, since functions are values and we can do value-y things to them, that includes passing them into functions. So, what if I wanted to make a function that takes in an array and then doubles everything in that array, or 1, 2, 3, 2, 4, 6 kind of thing. So numbers are going to be that, and I want a function that doubles numbers. So it takes in the numbers, and then I could do something like make a doubled numbers array, and then I could iterate through the numbers for let number of numbers, and then doubled numbers push number times 2. Okay, and then return double numbers. Should be able to follow the logic on that, okay? And if I log double numbers, let's see what I get back. Double numbers, what do you know? Okay, here's the problem though. What if I don't want to double the numbers? What if I just want to do some kind of transformation to the numbers? I don't know what it is. I want to double them. I want to triple them. I want to turn them into strings. Like, all of those are things I might want to do with a collection of numbers. So, like if this was triple numbers, I have to repeat an awful lot of code just to get that. That sort of sucks. So I could like pass in another thing. It's like multiply numbers. That's a little bit more flexible. But like still won't help me with like turning it into a string or anything else. So what I could do is have like transform numbers. So what if transform is a function? And what I do is I call transform on the number, and I push that in. Okay, that's something. How would I call such a thing? So I want you to think to yourself for a second. If I have that code, first argument stays the same. How would I write something that doubles? Think to yourself for a second, like a minute. How would you write that? All right, who can tell me? Volunteer.
Well, since number is a function, and you'd have to call it, couldn't you write like transform and then number times 2 within the parentheses? Because I don't see in the actual body that what transform does is specified.
It's not.
Yeah.
It's not specified at all. It's passed in as a parameter. So that means that I need to give it here. Oh my. How do I do that?
Could you do like transform? I want to say arrow function, but I don't know if that's right.
Ooh, an arrow function. Tell me more.
So you could do like, because that's the transform is the name. So
Yep.
like transform and then equals, and then your parameters could be like whatever number.
Mm-hmm.
Would you even need an equal?
Oh
If you're-
yeah,
if
do I
you're-
need the equals? And I don't need the transform either, because it doesn't, what it's called inside the function doesn't have anything to do with what it's called outside the function.
Because we've already defined it. So we
Yeah.
can just do the little fat arrow and do like number times 2,
Okay.
right?
Huh. I wonder if that works. Holy shit.
Holy shit.
So there's actually nothing special about these being numbers. Like, this is really just like an array. So if I say array, and then this doesn't have to be a number. This is just like item. These aren't doubled numbers really. They're like transformed. It's like a transformed array. It's not really transform numbers. It's really just transform. Well, hey, wait a minute. Just let item of array. Don't we have another name for transform? Can we just call it map?
Map.
Ta-da! That's how map works. I can bust this out. Oops. That might be easier to read.
So why wouldn't you just use like numbers.map and do the normal function?
Because then I wouldn't be able to demonstrate to you how a higher order function works on the inside.
Oh, okay. I thought that this was something we could actually do instead of map, and then okay.
No, that is like how map is
Long
written.
week. Okay.
You actually had us at one point like recreate all those,
Yes, I did.
and there's somewhere that's listed where we can see how that's done. I don't know where it's at.
Well, how about we make it?
That must have been a non-required exercise, huh?
That was no, that was in the morning warm up.
Oh, okay.
So I want to see if I give you this example. See if I can get inbox to work. Write an implementation for filter. Come on.
It's got a 404 error.
All right, well, just do it. Come on, Heroku. It's not free either. It pissed me off. So your task is write an implementation of filter, like a definition. So this is what map would look like. See if you can figure out what filter would look like. Go. Oh, actually, you know what? I'm going to make this easier. Let's just do for each first. It's the easiest one. Write a definition of for each. Go. right. So let's do a thumb scale. I want to see, could not get anything going. Thumbs down, thumbs up is working for me, and whatever in between. All right, lots of sideways, couple down. All right. So what a for each does is it takes in an array, takes in a function, calls that function on every item in the array. So that looks like this. So the loop is the same. But we don't need to push anything. Really, all we need to do is that. Por ejemplo, if I call for each with, oh, actually even better. I call for each, and then I pass in console.log. That's a function. Let's see what happens. Womp womp. Number. Oh, it's not called number
Does the
anymore.
console.log need the, oh.
Numbers. There we go. There we go. Logs all the numbers. Or I could write my own thing for it. It'd be like function that takes in a number and calls console.log on number. That's the same thing, but longer. Still works.
I was closer than I thought. I was just missing a few things.
There
I
you
got
go.
for let item of item, but or item of array, but then I was like, I don't know what to do now. So
There
That's
you
what
go.
I had.
So this is a function. Hey, we can call functions, can't we? So call it on each thing.
I named my parameter function. I didn't like that. But
No, it
besides
is
that,
not. Because function's a keyword. And so if you did want to do that, FN is what most people do. It's stupid. It's very programmer abbrevi. I would jump through some hoops to try to come up with a more descriptive name than that. But that is the alternative if you have to use a keyword. 'Cause yeah, you can't name anything in JavaScript function, for, let, const, any sort of built-in keyword kind of thing, fetch, not allowed. Ask me some questions about this.
So my definition of for each is for each element or target, execute a side effect.
Mm-hmm.
So in this instance, where we're doing for each, we have a parameter as an array and then an action, which can be anything.
Any function.
Any function. Okay. So in the body of the function, for let item of array. So basically, we're just pinpointing like each item in the array, which is the first parameter. Okay, I got it. Thank you.
We're iterating through the array, and then for every item in there, we do something. All right, do it again. Lots of sideways and thumbs down. So given this code, see if you can write a definition of for each. Try it again, another couple minutes. If you already have something on your screen, delete it, start over. All right, time's up. Give me a thumb scale. How do we do this time? Nice, nice. Lots of thumbs ups. Okay, much better. All right, so next, in case that you were not a thumbs up, one more time. Write a function called for each. It takes in an array and some function. We iterate through each item in the array. We call the action on the item. That's it. That's the tweet. Okay, cool. Next one, a little bit trickier. I'm going to get rid of our map also. Write a definition of filter. Delete your for each if you haven't already. See if you can do this one off the dome. Exercise some neural pathways. 2 minutes, write me a definition of filter. All right, thumb scale, how do we do? See some sideways, see some sideways, sideways. That's a little bit, thumbs up. It's a little bit better than we did on map the first time. So let's talk about it. So, if I'm writing filter, here, I'll write it as an arrow function. Takes in an array and a filter function. And then this one we do need to like accumulate it into an array. So this will be like new array, filtered array. And then we will do for let item in array of array. And okay, so the trick here is we need to call whatever the item is, you need to pass that into the filter function. Remember, filter functions return true or false, or truthy or falsy. So we can use that in an if statement to figure out whether or not it gets added to the filtered array. So that might be something like if filter function item. So filter function item, this expression will evaluate to true or false. So that determines whether or not this block of code runs. And in that block of code, filtered array dot push item. So if that evaluates to false, this never runs. And then we return the filtered array. So
did this completely different.
Oh yeah?
I did, yeah.
What'd you do?
Well, I did a function of filter numbers and just return the numbers dot filter. And then a number.
We're writing a definition of filter.
Oh, gotcha. Okay.
So if I console log that, I can call filter with numbers. And let's say my function takes in a number and determines whether or not that number is greater than 2. So let's do this one on the whiteboard and trace it. Okay, so numbers is 1, 2, 3, and this is a function definition. So that means this array is 1, 2, 3, and that filter function is number times 2. Filtered array is empty. For item of array, so item is going to be 1. Array is always going to be 1, 2, 3. If filter function, we pass in item. So item is 1. That means over here, that's 1, that's 1. Times 2. So that means that filter function, oops, sorry, that wasn't times 2, greater than 2. Was greater than, there we go. So we got 1 in. Is 1 greater than 2? Well, that's false. So that means this evaluates to false, which means this block doesn't run. All right, next one. Item is 2. So we pass 2 into there. That becomes 2. Is 2 greater than 2? Well, that's false. So that means that this is false again, which means that block of code never runs. So then item is 3. All right. So we pass 3 into there. That's 3. 3 is greater than 2. Well, that's true. So now that's true. That means this block of code runs. Filtered array gets 3 pushed into it. So now filtered array is that, and that's what ends up returning from this function. Do it work? There you go. Ask me some questions about it.
I'm so confused. Where did the array get defined in that? Like where was, oh, it was at the top. Okay, I'm just blind. Never mind.
Nope, just the same one from earlier.
So if you were going to write that in a function like definition separately, would you just do like if filter function item equals true equals true, and then return filtered array dot push item? Or
so like if I was gonna put this in a separate function,
would the filter, since you put it in like a map function instead of like a function, does that make, there's no function like there, it's a, what do you call it, a dysfunction?
I mean the filter function, this?
Yeah, I mean if you were gonna write that out long way instead of the map, would you do it exactly the same way?
Which
or
map?
It would just function equals, I think I'm not, because I started off doing like function, filter, and then you pass in an array and a filter function, then you declare the const. Would you change anything about that if you were doing it that way instead of the way you did it?
With the function keyword, you mean?
Yes.
Oh, not at all. That becomes that becomes that goes away. Otherwise, it's the same.
Okay.
Can you go back to the whiteboard for just a second?
Yeah.
Okay, thank you.
Questions about how the filter is working?
So just to clarify, I want to make sure that I'm not totally off base. What we see here on lines 19 through 29 is the dot filter that we used in Beyonce and Pokemon and all these things.
Does the exact same thing. Difference is we're not dotting off the array and calling filter. We have to pass the array into it because we're defining it, not JavaScript. But it does the exact same thing, yeah.
Perfect. Just want to make sure.
Yep. And if you were like to look at how your browser defines filter under the hood, it's probably not so very different from this.
If we were going to do this as a dot function, would we do the const numbers equals that array and then dot filter after that? And
it's just array dot filter and pass in what you want, right?
Yeah, so the alternative would be like numbers dot filter and then like that's the way that we would use it with the built-in one. That's our like custom one that we made. Questions about filter? All right, let's do one more. Let's do find. Write a definition of find. 2 minutes on the clock. Go for it. All right, pencils down. Give me a thumb scale.
Cautiously optimistic. Not true, sure.
We're kind of all over the map. All right, thank you. So, find is going to take in an array and a matcher. It is going to iterate over each item. Item of array. And what we want to do is we want to call the matcher with the item. If it returns true, we found our match. So if matcher item returns true, return item. If you want to be like super slick, otherwise return null. Does it work?
So if there were,
Go ahead.
if there were multiples, so like let's just say there was another one in there, and how do we stop it from continuing to map through?
Great question.
Go through.
Return ends the function. So even though it's inside of this thing that's iterating, the first time that happens, done. The function calls over at that point. Let's walk through that. Well, first of all, let's make sure this works. So if I do find numbers, and then my finder function is, I want to find the number that is 2. Number. Then this all right, do it work? There we go. All right, so let's trace this one. Okay, so we called find with numbers. Numbers is 1, 2, 3. And we have this function. So that means when we call this, that's 1, 2, 3. And this is that. For item of array, so array is that, will always be that. That's 1. If calling matcher, that's this thing up here, with 1, so that becomes 1. 1 is 2. Well, that expression evaluates to false, so that means that all of this is false. So that block doesn't run. Okay? Then item becomes 2. All right? So then we're passing in item. That's 2. 2 equals, or 2 is the same as 2. So that evaluates to true. So the find function returns 2. Questions about find?
Can you run it back for me one more time?
Love to. That's all I want to do. Okay, numbers is the array 1, 2, 3. That means that is the array 1, 2, 3. And this is this function. So that's what gets passed into find. Find is over here. If we connect those, that means that one's that. And this matcher is that function. For every item in the array, so the array is 1, 2, 3. An item in the array is each of these. The first one's 1. If matcher, because remember, matcher's a function. Even though we just passed it in, it's still a function. That means we can call it. We can invoke it with parentheses. If I pass 1 into that, it goes... sorry, come on, Hager. If 1 is 2, well, that evaluates to false. So that means that this expression evaluates to false. So that means this block never runs. All right, next iteration. I do 2. I pass in 2. 2 is 2. Well, that evaluates to true. So that means this evaluates to true. That means this code block runs, which means that returns 2.
That makes
So the parameter of find at the bottom, the number, arrow number equals 2 is the matcher. That's what you defined it because that's the parameter that's given that matches that part of it. Okay.
Brad, you just connected it. That's what it is.
Okay.
So, like with filter, you're getting all the items and you're returning an array with everything that met that criteria.
Correct.
What if you wanted that to do, would you just do a for each instead of a find to get everything that matched that number instead of stopping at the first example? Because if it's only returning one element, that's the value, but you wanted all of them in an array.
Sure.
That's when you would do like the for each to go through it to find every single thing that matched.
Ooh. Don't we have another one that gives you every match?
Filter.
That's what filter is.
Oh yeah, I guess you're right. Duh.
You're pushing like all everything that's being filtered, you're pushing into a new array.
Because there's nothing that says you have to do just greater than. You could do the equal and get your own. Okay, yeah.
Absolutely. I want to find the first thing that's greater than 2. That's fine.
Yeah.
If I rewrote my filter, like that. For each item in array. So this one I need some array that I can keep track of. So this is like the filtered array. Like that. That's always going to be the thing that gets returned. If matcher item is truthy, instead of returning it, we do filtered array dot push item. But then otherwise, those are the exact same stuff. So I made that a little bit lower.
So it's just knowing whether or not you want an array or if you just want one element.
Correct. So that one is going to give me 2 because that's the first number that's bigger than 1. This one is going to give me 2 and 3.
So isn't there also quite a vast difference between these two? Because in find, I got a value back, and in filter, I got an array back. What if, going with Julie's desires here, I don't want an array back. I want a series of values that are greater than 2.
All right, you're about to like put together something huge. What is a series of values?
An array.
An array.
Right.
Okay.
That is what an array is.
Yeah. All right. Sweet.
More questions about this?
I think my hangup originally was like looking at matcher, and I was like trying to figure out in my head like what is matcher, and so like what Brad said. Thank you, Brad, because like we have to basically give it a body at the end, and so when we call this function of find, the second parameter is the function, so we gotta plug it in there, and then bam.
Yes.
It makes so much sense.
So now when you do the built-in ones, like numbers.find, number is greater than 1, or filter, same shit. That's all that's happening
this is
when
where
you're
I'm
doing that arrow syntax thing.
This is where I'm struggling, because how I wrote my function out was exactly what you just did down below the numbers.find, numbers, arrow, fat arrow number, and I did greater than 2, but I'm struggling to understand in the function that we wrote up above why that does the same thing that this one does.
So the only difference between these is with the ones that we wrote, we have to pass the array in. We don't call it on the array. You can write your own ones that like, those are called prototype methods. Hey, remember that prototype thing? Like they're way more complicated than they're worth though. But otherwise, if I were able to call it on that, it's the same thing, and it gets the array the exact same way, really. But it's doing so. This one we get it built in. This one we had to define it and do all the work ourselves. But under the hood, these built-in ones, their implementation looks probably a lot like this. Takes in an array, iterates through the array, uses that function that you defined, and passes each of those items into it, and then uses that to figure out whether or not it should push something into this. And then regardless of if maybe nothing matches, all right, well then you return an empty array. Maybe everything matches. Cool, well then it's just a copy of the array.
So oh, sorry, go ahead.
Bryce, let's stick with Bryce for just a sec.
Sorry, so like in the top example up on line 19, if instead of, if we were to say function find number, so the singular of the array numbers, and then still have our matcher function, and then we change that to number, and then we're still finding an matching a number, and it's going to return a number as opposed to item. Like those are all things that we can change as far as naming.
None of the names here matter. So this could be called A.
They're truthy.
This could be called M. This could be called I. That's the same function.
So the only difference between find and filter is you're giving it an empty array and telling it to push the items in, and then find it just finds the first one, but it doesn't do anything after that.
Correct.
There's nothing else for it to do.
Nothing else.
And you don't get an array back.
Correct.
Yeah. Because you didn't give it an empty. You didn't give it an empty array, and you didn't tell it to push anything into it.
Yep.
So it's like filter is an addition to what find is. It's like find plus 2 or something.
Ding, 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 ding.
Find all.
Yeah. Find versus find all. Love it. Other questions?
So is map, because map transforms.
Yep.
And it's all matches. So technically is map like a cross between like filter and find? No, right? Because because filter is like the first match.
Filter's every match.
Filter's every match. Find is the first match.
Correct.
Right. So like, so map is like filter, and then map is like filter, pretty much.
So
you're telling it where to go. Yeah.
The difference is that with map, takes in an array. It takes in a different type of function. So matcher's like a really handy, like human-friendly thing to call it. That's not what it actually is, though. It's called a predicate. That's also a predicate. A predicate is a function that returns true or false. That's it. So it's really good for both of these situations because we're using it in a conditional. So we can say like, all right, if calling that evaluates to true or evaluates to false, then that gives us something to do. The transform is a little bit different because it ends up being structured really similar to filter. Like the first part and the last part are the same. So that's going to be like, instead of filtered array, transformed array. Okay? We iterate through it the exact same way, but there's no conditional to it. Everything makes it in, but we're calling transform on every item. So whatever transform returns for that item, that's what gets added to the array.
So when you call the function, whatever the transformer is, the second part of the parameter you're putting in it's going to be applied to all of the things. So if it's times 2, it's going to be whatever, like
and you
the
use
array
the word
times
apply.
2.
Yes.
Yeah.
Because if we have this array, and we have this double function, it just gets applied to each of those values. To create the new array. You're applying that function to that value to make your new value. That's mapping. And in code, it looks like that.
I think the biggest takeaway for me is just, like, I didn't realize this until today, is that you're giving the parameters a meaning when you're calling it.
Yes!
There's nothing there. It's like you're actually putting the meaning in when you're calling it. You're telling
Yes!
it what to do for those transforms and whatnot.
Oh, Brad, you found the beat. That's exactly what it is. You are defining what gets done with each of these. That's what that is. All right. Sounds like it's time to go to GatherTown. Oh, and you're all here. All right, so GatherTown is a different app